All right, let's jump right in. Today, we're going to dive deep into one of the biggest questions in tech right now. How do we actually make AI trustworthy? We're going to go on a journey from cracking open its mysterious black box to looking at the guardrails being built to keep it safe, reliable, and, actually working for us.
And let's start with a story that's all too real. I mean, think about this for a second. This isn't some science fiction problem happening in the future. When an AI just makes stuff up, when it hallucinates, the consequences are immediate. We're talking about someone's reputation on the line, real legal battles. This one incident just perfectly captures why getting this right is so incredibly important.
So, what's at the heart of the challenge here? Well, it really boils down to something that researchers call the black box problem. The thing is, we're starting to rely on AI for some seriously important decisions, but a lot of the time we have almost no idea how it's coming up with its answers.
To put it simply, a black box is kind of what it sounds like. You can see the information that goes in, you can see the answer that comes out, but everything that happens in the middle is a complete mystery. And with these huge deep learning models, we're talking about systems with hundreds of billions of moving parts. It's so complex, it's literally impossible for a human brain to trace the logic from start to finish.
And this is the crucial part. This isn't just about a chatbot getting a poem wrong. AI is already being used in hospitals to read medical scans. It's in banks deciding who gets a loan. It's even being used in government to figure out how to spend public money. The stakes couldn't be higher, which means understanding what's in these black boxes is absolutely non-negotiable.
Now, here's a tricky thing. It's not always about a model that was built with a flaw from day one. Sometimes, a perfectly good, accurate AI model can just slowly and quietly start to fail. It's this really subtle but dangerous threat that anyone using AI has to watch out for.
You see, unlike regular software, which is pretty much set in stone until a programmer updates it, AI models are in this constant state of what's called continuous silent degradation. Think about it. The world is always changing, right? People's habits change, the economy shifts, new trends pop up, and as the real world drifts further and further away from the data the model was originally trained on, its accuracy just silently fades away. So how do the experts actually fight this silent decay? Well, they have to constantly peek inside the box to see what the AI is thinking. This table here, it gives us a little glimpse inside a fraud detection model. These features are just the clues it's looking at, like how much money was spent or where it happened. And that coefficient number, that tells us how important each clue is to the AI. A big number next to transaction amount means the model is really paying attention to it. By keeping an eye on these numbers, data scientists can spot when the model starts getting confused and its logic starts to drift.
Okay, so we've covered models that go bad by accident, but what happens when someone tries to corrupt an AI system on purpose? Well, that opens up a whole new world of hidden threats that are a lot harder to spot.
Attackers can be pretty clever. They can sneak in these back doors at almost any point in an AI's life. During training, they can poison the data, basically teaching the AI a secret malicious trick. Then, when the AI is being used, it looks totally normal until a specific trigger, like a certain word or a weird image, makes it go haywire. They can even mess with the model's core files while it's in storage, or attack the other software it relies on to run.
And this right here, this slide perfectly shows the cat and mouse game of AI security. For every type of attack, a defense is being built. If they try to poison the data, you fight back by carefully checking where all that data came from. If they tamper with the model's files, you use digital signatures to lock them down and make sure they're legit. It's this constant, ongoing arms race between the attackers and the defenders.
Okay, we've been pretty deep in the technical weeds, so let's zoom out a bit. How are we trying to manage all these risks at a much higher level? We're starting to see frameworks and rules being built to create a system of trust around AI.
The good news is there's a global consensus starting to form around what good AI should look like, and it's based on principles just like these from the OECD. The big idea is that AI has to serve people. It has to be fair. It has to be understandable. It has to be safe. And at the end of the day, someone needs to be held accountable for what it does. These principles are basically the North Star for guiding AI policy around the world.
And to turn those big principles into something you can actually use, you have frameworks like this one from NIST in the US. This isn't just theory. It's a practical playbook for any organization out there. It walks them through a clear process. First, figure out what could go wrong. Second, analyze how bad it might be. Third, decide what you need to fix first. And fourth, actually go out and manage those risks. It's a clear roadmap for being responsible.
So we've got the big picture rules of the road,
But down on the ground, how do you actually prove that a specific AI model is safe before you let it out into the world? This is where things get really cutting edge.
First, we got to understand why this is so hard. Traditional software is predictable, right? It follows a set of rules. It's like a calculator. 2 plus 2 is always 4. And if it breaks, it usually breaks loudly with an error message. AI systems are totally different. They learn from patterns, and they make guesses based on probability. They don't fail with a clear error, they just get quietly less reliable over time. So we need brand new ways to check their work.
Now, don't get bogged down in the names and numbers on this table. The real takeaway here is to see the massive scientific and computational effort being poured into this problem. These verifiers are super complex algorithms that are trying to mathematically prove that an AI model is safe. Every problem they solved here is a victory. It just shows you the incredible rigor that's needed to build real confidence in these AI systems.
But sometimes, the most advanced solution is also the one that just makes the most sense. A huge strategy is called human in the loop. For the most critical decisions, the AI doesn't get the final say. It does its analysis, it makes a recommendation, but then a human expert steps in to make the final call. This way, you get the amazing speed and scale of AI combined with the common sense, judgment, and accountability of a person. It's the best of both worlds.
All right, let's pull all of these threads together for the big takeaway. We've seen the problems, we've seen the attacks, and we've seen the solutions being built. So what does it all mean for the future of AI, and for us?
If there's one thing to remember from all of this, it's this. Trustworthy AI is not a one-and-done fix. You can't just install a trust update. It's an ongoing process, a discipline. It means you have to constantly monitor for that silent decay, you have to stay vigilant against new attacks, and you have to stick to those governance frameworks. Trust in AI has to be earned and re-earned every single day.
Which leaves us with one final huge question. As AI gets woven into the fabric of our lives, making decisions about our health, our money, and our opportunities, who's ultimately on the hook when it's wrong? Is it the person who wrote the code? The company that used the AI? The group that supplied the data? This is the great societal and legal challenge that we all have to figure out together.